I'm going to be going over a bunch of factoring techniques, and I'm going to start out with factoring out common factors, also known as greatest common factoring. So for greatest common factoring, in this first example, we're going to be looking at the numbers first. So we're going to figure out a number that all of those can go into, and so we can take out a 2. And then the next thing we're going to look at is the x terms. And so we're going to say that the biggest x term that we can take out is just an x. And then when we look at the y terms, the biggest one we can take out is a y squared. So what we're left with is, if we were to distribute this out, we need to get this 8x to the fourth y squared. So 2 times 4 is going to give me the 8, and x times an x cubed is going to give me the x to the fourth, and we don't need a y. And then a 2 times a 3 is a 6, and x times an x squared gives me the x cubed, and we need one more y to get the y cubed. And then here we're going to have a minus 1, and then we just need a y squared to get it to be a y to the fourth. And this would be factored. In this next example, we actually do have a greatest common factor. This x minus 5 is common to both. So just like we took it out in front of the parentheses here, we're going to take the x minus 5 out in front and then figure out what we need to multiply by to get this term. So we would need to multiply that by an x plus 1, and then here we'd need to multiply it by a negative 3. And so what we have when we combine this is an x minus 5 times an x, and then we have a 1 minus a 3, or minus 2, and that would be considered factored completely. And this last example for this factoring out common factors, or GCF factoring, you'll see that we have a w plus 8 in common, so we're going to go ahead and do the exact same thing that we did before. And then what would be left over when we distribute, I would need a w squared, and then when I go ahead and distribute here, I'd need a 5, and that would give me what is factored completely. The next factoring technique that we're going to talk about is difference of squares. So if we're given two square numbers and you're subtracting, difference means subtract, you can factor this into a plus b times a minus b. So this first example, we have x squared minus 16, and you have to know your perfect squares. So this is the same thing as x squared minus 4 squared. So that's your difference of two squares. So then this would go ahead and factor into, not a, but x plus 4 times x minus 4. And if you were to distribute this guy out, so if you were to go ahead and use FOIL, you'd notice that you get that term back. So in this next example, you'll notice that I don't have a difference in two squares, but in some cases you're going to have to factor first. See how we have a term that's in common? So we're going to start off with GCF factoring. So I'm going to go ahead and take out a y, and I'd be left with 49 minus 4y squared. And this is a difference of two squares because 49 is 7 squared, and then I have 2 squared is 4, and that's 2y squared. So if I were to go ahead and simplify that, I would be left with, in this case, a would be 7. So I would get 7 plus 2y times 7 minus 2y. And if you were to distribute that back out, you would notice that you would get that same exact original expression. So the next technique is factoring a quadratic, ax squared plus bx plus c. And before we start, I want you to remember back when you're multiplying two binomials and you use FOIL. So if you were to multiply this out, the first thing that you would multiply out would be the first, and so you'd get a 3x squared. Then you would multiply the outer, so that's the O, and so then that would give me a negative 6x. Then you do the inner, that's the I, and that would give you a positive 8x. And then last but not least, you would do the last, and that would give you a minus 16. So when you were to simplify this guy, you would have a 3x squared, and then the outer plus the inner is going to give me a plus 2x, and then the last is the negative 16. So when you have your expression, this is the first, this is the outer plus the inner in FOIL, and this is the last term. Now I say this because this is going to help us when we factor or we try to go from this step to that step. So what we're going to go ahead and do is we're going to factor this, the 6x squared plus 7x minus 5. And so just like we had here, this first term that we had down here, that was the first. So when we make our two parentheses to factor, the first has to multiply to the 6x squared. So we're going to go ahead and try a 3x and a 2x. And again, these aren't the only two. It could be a 6x and an x, but it's guess and check. So we're going to try this. And then this part right here is the last. So these last two have to multiply to a negative 5. So I could either try the 5 and the 1, or I can switch the order. And then this middle part right here is the outer plus the inner. So these two guys, the outer plus the inner, have to add up to a 7x. Now right now I have this multiplying to a 15x, and I have this one multiplying to a 2x. There's no way that that's going to give me the 7x. So what am I going to do? I'm going to try to switch the 1 and the 5. So now I'm going to go ahead and put the 5 here and the 1 there. And then now this outer ends up multiplying to a 3x, and the inner multiplies to a 10x. So to get these two to add to a positive 7x, I need a positive 10x, and I need a negative 1 right there. So now these multiply, the last multiplies to the negative 5, and I factored it completely. You can always multiply it back out too if you want to make sure that it's factored correctly. So we're going to go over various factoring techniques. The first one's by grouping, and you're going to be factoring by pairing up terms. And usually this technique is done when there are 4 terms, so not 3. With 3 we usually use guess and check or diamond factoring, but when there's 4 we usually factor by grouping. Alright, so here's your first example. Alright, so I want to factor this, and notice that there's 4 terms, so we're going to use this technique called grouping. And you're going to group the first 2 terms, and you're going to pair up the second 2 terms. And what you're going to look for is you're going to look for things that are common in the first group. And the thing I can take out would be an x squared in the first group. What would be left would be a 2x. So if I were to distribute that back out, I would get the 2x cubed. And then I would have a minus, and then I would have a 5. Because if I were to distribute that out, I would get that term right there. Alright, now in the second group, I can take out a positive 9, because 9 goes into both an 18 and a 45. If I take out a positive 9, I'm going to be left with a 2x, and then a 9 times a negative 5 is going to give me that negative 45. Sorry, that was the bell. Okay, so now, what you have is you can now factor. See how you have something common? In order for grouping to work, those have to be common, always. So if this is common, then what you can do is you can take it out, since it's common to both. And what you're left with is what's left over, an x squared plus a 9. So if you were to distribute all this back out right here, I would end up getting this original polynomial. So I have just factored it by grouping, so this would be your result. Now if this can factor further, you would, but because this is a sum of squares and not a difference of 2 squares, you're done. So in this next example, we're going to do the same thing. We're going to go ahead and group them together, or pair them up, and then we're going to factor each pair. So in this first one, I can take out an x squared. That's the most that's common. So what would be left would be a y squared minus a 3. Now, in the second part, I'm going to take out a negative 4. And so what I'd be left with is a y squared, and a negative 4 times a negative 3 is a positive 12. So again, notice what we have. We have stuff common. So if I had only taken out a positive 4 here, I wouldn't have had these be the same. So you have to get them to be the same if you're going to factor by grouping. So I'm going to take out what's common, the y squared minus 3, and then what I'm left with is the x squared minus 4. So I am not done though, because if you remember, this is a difference of 2 squares. So I have the y squared minus 3. 3 isn't a perfect square, so I can't factor it. So then I'm going to factor this into x plus 2 times x minus 2 to get my difference of 2 squares factored so it's complete. So since we just factored a difference of 2 squares, we can actually factor a difference of 2 cubes and also a sum. And we couldn't factor a sum of 2 squares, but we can do it for cubes. So here's the formula. If I have a cubed plus b cubed, I can actually factor this using the formula a plus b, so whatever the a and the b are right here, times, I'm going to square a and then subtract off whatever a and b are multiplied together, plus b squared. That would actually, if you were to FOIL this out, you would actually get that right back. If you don't believe me, you can go ahead and FOIL it out and check it out, but this is how you're going to factor. So what we're going to be doing is we're going to be factoring this x cubed plus 125, and you're going to need to know your cubes. So I'm going to do a list of them over here. Alright, and so, sorry again, dang bell. Alright, so we're going to have our cubes, and we're going to go ahead and evaluate them. So you have 1 cubed, which is 1. 2 times itself 3 times is going to give you an 8. 3 times itself 3 times is a 27. 4 cubed, I believe, is a 64. 5 cubed, 125. 6 cubed is a 216. Let me try that again. 216. And a 7 cubed is 343. If you want more, you can write more down. This is going to help you when you factor. So this is a sum of 2 cubes because 125 is 5 cubes. See how it's 2 cubes added together? So we're going to be basically plugging them into this formula. X is going to be your A in the formula, and 5 is going to be your B in the formula. So if I were to factor this out, it factors into x plus 5, because that's my A and my B, times, I've got to square A, so that's going to be an x squared, and then I'm going to subtract off the product of A and B, or 5x, since that's our A and B, and then I have plus a B squared, so 5 squared is 25. This will not factor. You can try diamond factoring if you want, it won't. So you have your complete factorization right there. You're done. Alright, now in this example, it actually is a sum of 2 cubes. And if you want to figure out what number cubed is 8, you just look over here and you go, oh, that's 2 cubed, so this is 2 cubed. And then what number cubed is z to the 6th? It wouldn't be z, it would be z squared. So your A is going to be 2, and your B is actually going to be z squared when you use these formula, or that formula right up there. So if I were to go ahead and factor it, I'm going to do A plus B, or 2 plus a z squared, because that's my A and my B. And then I'm going to have to square A, so I'm going to square the 2, so I get 4. And then I have minus, and then I have to multiply A and B, so I'm going to get a 2z squared. And then I have a plus, last but not least, a z squared, which is B, but I have to square that to get z to the 4th. And then this would be that factored. So you can also do it when there's other powers. You just have to figure out what that power would be cubed and then go from there. Now I told you there was also a difference formula for 2 cubes. And so it's very similar to the last one. If you have a cubed minus b cubed, it actually factors into a minus b. So if this had been plus, then this would have been plus. So those are the same sign. And then what we had was a squared, and then on the other one it was minus ab. This one's going to be plus ab. So check out the difference between the two formulas. These two signs are always the same, and then these ones are always opposite. And in each of the formulas you can kind of see the patterning there. So let me give you an example. So we have 27 cubed minus 8, and so we have to figure out, well, it's a difference of 2 cubes. I have to figure out what cubed minus what cubed goes in there so I can know what A and B are. So I'm going to have a 3x, because a 3 cubed is 27, and then a 2 cubed is 8. So my A is going to be the 3x, and my B is just going to be 2. Just what's between the sign. You don't have to take the sign with it. So when I go ahead and factor it, I'm going to go ahead and get a 3x minus a 2, because it's the A minus the B. It'll always be minus here. And then times, and then you're going to square A, so I get a 9x squared, and then it's going to be plus A times B. So we're just looking at what's here, not the sign. So I'll get plus a 6x, and then I'll get a B squared, which would be a 2 squared, or a plus 4. and this would be completely factored. So if you don't believe me, again, multiply this out, use your foiling skills to see if you end up getting that. So the last factoring method we're going to go over is combined factoring, and you're going to need to use more than one factoring method, thus the word combined. And so what I would suggest you trying to do is always start by GCF factoring. That means look for a number or a variable you could factor out. So let's go over an example. So this problem, you have a 16x to the fifth minus a 250x squared. First thing you want to do is start trying to take out stuff that's common, and we can take out an x squared, and I think we can also take out a 2, because I think a 2 goes into 16 and 250. So I'm going to take out a 2x squared, and what I'd be left with is an 8x cubed, because remember you multiply, you add the exponents, minus a 125. Now, you're not done, because this right here is a difference of 2 cubes. That would be a 2 cubed minus a 5 cubed. So what you could then do is you'd use your factoring technique. Remember, this was a and b in the formula. And then you'd go ahead and factor it. So I'm going to bring down the 2x squared, and then I'm going to go ahead and factor. Since this is minus here, the minus goes down there. And I have an a minus a b, so 2x minus 5. And then you're going to square a to get 4x squared. These are always opposite signs, so then it's going to be plus, and then you're going to multiply a times b, so you get a 10x. And then last but not least, you have a plus a b squared, which would give you a positive 25. So now you'd be considered done factoring because you've factored it completely. Again, once you do the cubes, this guy's not going to factor.